This lab consisted of an analysis of constant velocity. Before looking at the lab itself, what is velocity? The scientific definition of velocity is the derivative of a body's position at time t. And this definition is the equation v of t, which is a vector indicating the speed and direction of motion. The formula at the bottom of the screen is the instantaneous velocity formula, where r is the position and t is time. The triangle-shaped symbol is referred to as delta. This signifies change, so delta t is change in time. If the velocity is constant, the object is moving at a constant speed along a straight line. This lab explores an object moving in a straight line with no change in speed as seen in the graph. By analyzing an object in motion, the question, how can the position of an object be measured over time, will be answered. Think about this. Velocity is measured using the derivative of an object's position with respect to time. This explains the unit of velocity, which is meters per second. In this lab, the primary principles explored are Newton's first and second laws of motion. Newton's first law states that an object in motion will stay in motion unless acted upon by a force. Newton's second law of motion says that the rate of change in momentum is equal to the vectorial sum of force on a body. This law relates to net interaction of systems and surroundings, also known as net force, to the observed motion of the system, which is known as change in momentum. For the purpose of this lab, the motion of an expo marker was observed. To have an idea of what may be concluded in this analysis, think about this. Using Newton's first law of motion, what will happen when an expo marker is rolled on a laboratory countertop, and what will stop the object from rolling? Newton also explained that the net force or sum of forces can equal zero, even if there are forces acting upon an object. Imagine the same force in two different directions, or the sum of -2 and +2. This is an important note to remember when analyzing any motion in physics. Think of pulling a rope that is wrapped around a heavy box. In this example, friction will be the force at play, as seen in the drawing. In any physics scenario, there is the case of systems and surroundings. The system is the object being studied, and the surroundings are everything else. In this scenario, the expo marker is the system, and everything else is considered the surroundings. This is important to note as the system has an effect on the surroundings, just as the surroundings have an effect on the system. This is known as an interaction. An interaction is identified through change. This can be change of motion, speed, and other physical properties. Since the velocity observed in this lab is constant, there will be no net interactions. This lab involved rolling an expo marker in the positive x direction. The goal of this lab was to find the object position and time based on a video recording of the object in motion. To construct a video analysis, the initial conditions must first be identified. In this case, the initial velocity vi, the initial position ri, and the initial time ti were all considered to be zero. This is useful for both the prediction and the actual data. To compute this, a range was chosen in a shorter interval than that of immediately after rolling the object. Then a meter stick was used as a known length for calibration. Since the entire meter stick is not in the video, the measurement was 0.7 meters or 70 centimeters. The motion in this video was described by placing the origin at 0, 0 centimeters. This means that the expo marker is moving in the positive x direction and none in the y direction. The y direction is assumed to be negligible. From here, acknowledge object's position in the video frame. Mark average location of the ball using point mass several times throughout the frame. This will give the position versus time graph and table. From here, a video analysis was done to calculate the average velocity using the first two inputs from the graph as seen on the screen. The average velocity was calculated as 0.2971 meters per second. This is the observed position and time. In the last slide, the observed calculations came from Tracker, which was used for the video analysis. Next, a computational model was constructed using Newton's second law. Using a provided starter code, necessary values were input in their respective places. These values included the object's mass, initial position and velocity, and time of last observation. The purpose of this section of the lab was to create a motion via a computational model that was similar to the real motion observed. This is known as a simulation. Using an Excel spreadsheet, the observed and predicted position and times were compared. Important physics. Newton's law and velocity in this lab. The object was in fact acted on after the video stopped as it was prevented from falling off the counter. We will get back to this in just a second. How would results change if the axes were flipped and the positive x and negative x were interchanged? This would cause the object to seemingly move in the negative x direction as seen on the graph. What does it mean? As mentioned before with Newton's law, there were applied forces as the object was rolled, normal forces from the counter, friction, and gravity.